Hello everyone, this is Tiago from Envea, and I hope you're doing fine wherever and whenever you are. In this video, I want to introduce to you Envea Process product portfolio. So grab your cup of coffee and let's have a chat. The Envea group is divided in three divisions: ambient, emissions, and process. And an Envea process is part of the process division. Jumping to the products, I like to divide them in four different categories: mass flow measurement, material flow monitoring, material moisture measurement, and emissions, with a focus on ambient air monitoring and bag filter monitoring. The very first product we're going to talk about is the solid flow. The solid flow is a mass flow meter for bulk solid materials. It works with the microwave technology, counting every single particle which passes by the sensor. It creates a microwave field inside of metallic pipes, so metallic pipes are always required. And it measures using the Doppler effect, counting the particles' reflections. The sensor can be used in two different situations: free-fall applications and pneumatic conveyance systems. What is very important to keep is the diluted phase. The particles should be very well diluted inside. The sensor is not intrusive. There's no moving parts, nothing to break or wear over time. Solid flow should be installed always after a conveying device. Having a good conveying device helps us to have a good measuring application. The sensor works well in small flow conditions and bigger flow conditions, going all the way to 20 tons an hour. And the installation, it's quite simple. It's basically welding the weld-on socket into the pipe, drilling a hole through the weld-on socket and inserting the sensor. And that's all. Sensor sends a signal to the evaluation unit, and from the evaluation unit we can get Modbus, Profibus, 4020 mA directly to your PLC. The solid flow is a quite compact device, and one thing that makes it even better is the ability to understand the flow inside the pipeline using a very advanced algorithm. And with this technology, the sensor can predict the flow inside, delivering a better and more accurate measurement. The solid flow can be used in a big variety of applications, such as coal, cement, limestone, spices, additives, flour, and the list goes on. Just find a good conveying device, free-fall or pneumatic application, mixing process, feeding process, and then you get an online flow measurement. Easy to install, compact, and reliable. And now let's jump to the big brother, the Max Flow. The Max Flow is a mass flow measuring device for bigger range applications, going even up to 250 tons an hour, 300 tons an hour, but respecting the concentration inside to have a safe application. Inside the sensor, there's two main measurements happening: density and velocity. And using the cross-section information, we can calculate the mass flow. What makes the max flow different from the solid flow is its form factor. The sensor is now part of the pipeline with a fixed diameter, but internally it has a ceramic inlay, keeping the sensor resistant against abrasion and wear. Another thing, the max flow should be used only in free-fall applications. One thing regarding the applications is that the max flow targets free-fall applications, no more pneumatic applications. To get a good measurement, the sensor requires a good concentration inside. The material flow should fill the sensor to have a higher signal and a better accuracy. Vertical lines, inclined lines are well accepted. And just between us here, the Max Flow is the best replacement for the old impact plate meters. The Max Flow is easier to calibrate. It is stable over time. There's no moving parts, no mechanical parts to break. There's no problems with dust or abrasion. And calibration is so much easier to do. And you can have max flow measuring cement, gypsum, flour, and many other materials. In addition to it, we can make sure we are always injecting material into the process. Different lines, different lenses. Do you remember about the PCI application? We can have flow guns around the oven as well. We can have flow guns in between two screw feeders. But what is a flow gun? Let's talk about it. The flow gun works with the microwave technology, using the Doppler effect again. Is it like a solid flow? Sort of, but now targeting just flow detection. It has the same Doppler effect technology, but it gives you just one alarm, just to inform that the material is flowing. Similar to the solid flow, flow gun can work in two different applications, pneumatic again and free fall, but with less restrictions. It goes in vertical lines, inclined lines. We just have to make sure the material is flowing inside. Then flow gun is ready to detect. For chute and silo monitoring, we have the Progap. The Progap has transmitter and receiver. Progap works with the microwave technology. Using sensor and transmitter, the distance between them can be up to 25 meters, covering very large diameters. Progap is very versatile because it uses the same process adapters as a flow gun. It goes in high temperature, high pressure, food applications, and more. For tube monitoring, the mine industry used to install those rotary sensors for flow-no flow monitoring. But those sensors used to break quite easily and quite often. Having a contactless material detection, we avoid breaking the sensor. So Progap is basically one-time purchase. And for silo level monitoring, Progap has the same advantages comparing to the old rotary plate sensors. It doesn't break over time, it doesn't clog, it's a contactless monitoring. Once installed, it just works. And now we can talk about moisture. Material moisture measurement, not ambient moisture, but material moisture. Something that was done previously only using in the laboratory those old thermal scales. We're now bringing the moisture measurement from the lab, something that was only done once every hour. We're now doing every second using the Msense. The Msense works with a high-frequency contact-based measurement. The material should be always moving, always renewing on top of the sensor. We don't want gaps in between material and sensor. They should be always in contact. The Msense is a very compact sensor which should be installed always in conveying devices, always in points where the material is moving, such as conveyor belts, on top of conveyor belts, underneath screw feeders, closer to dryers or even inside the dryer, and hoppers. And once again, we just have to make sure we have a stable flow, and a stable material layer on top or underneath the sensor. With this information in hand, we can have Msense measuring organic materials, minerals, pulverized, granulate, wood chips, pellets, and much more. The Msense family has three different sensors. Msense 3 for moisture and temperature information, so two analog outputs. Once again, 4020 output, Modbus, Profibus. The Msense 2 doing only moisture measurement, and the Msense WR for a wide range applications, only with moisture measurement. In every application that moisture matters, Msense is the right way to go. It's compact, affordable, and easy to calibrate. As you may know, Envea has the entire portfolio for emissions measurement. But in this video, I want to share with you just the entry level for bag filter monitoring. Let's begin with Dusty. Dusty is basically a plug-and-play device. You install it after a bag filter in a clean gas side. As soon as you have a broken bag, a higher material amount flows to the chimney stack, and using the electrodynamic technology, Dusty detects the high material volume and gives just an alarm telling there is a broken bag inside. Dusty is an affordable device, compact and very easy to adjust. But Dusty is just the first step into the emissions measuring range. And what should we do when we want more than just an alarm? When we want measurement in milligram per cubic meter? Then we jump to the Msense. The Msense uses Envea's electrodynamic technology, monitoring everything that happens inside the pipeline. The sensor goes on the chimney and it has an external evaluation unit to deliver 40-20 Modbus and Profibus outputs. Using the isocinetic sampling or dosing method, the Msense can be calibrated, giving an accurate measurement in milligram per cubic meter. And it goes from 40-20 output, Modbus communication, Profibus, directly to your PLC. And we have adapted the same electrodynamic technology to a more compact device, the Airsafe II. The Airsafe II is an ambient air particulate concentration monitoring device. With this longer description, basically what Airsafe II does is monitoring the amount of particulate in rooms, storage areas, and outside, just to make sure that those concentration levels are below an important alarm level. Yeah, that's the end of our chat. So if you have any further question regarding material flow measurement, material flow-no flow detection, material moisture measurement, emissions measurement, I'm quite sure there's someone from Envea next to you. Thank you very much for watching. My name is Tiago Morais, and see you next time with more solids and gas measurement. Ciao, ciao!